Right, good evening, everyone. Today or this evening, I will be going over um, the binomial distribution and the Poisson distribution. This I'll make this recording available tomorrow, the 17th of April. So just ensuring that it's recording. Yep, perfect. Okay, so as usual, I'm going to share my screen. Um, and then continue. Okay. Um, I have Stefan joining. Stefan, can you just give me a heads up that you can hear me and that the audio is fine, as well as seeing my screen? I have the whiteboard here. Uh, Let me just draw something in blue. And if you can just give me a heads up that you can see it. Perfect. Perfect. Thank you so much. All right, so let's begin. So as I was saying, today I'm going to be covering the binomial distribution and the Poisson distribution, which I believe falls under Learning Unit 6. So I'm actually going to split up Learning Unit 6 into two collabs, and next week I'll cover the normal distribution. All right, so today it's going to be the binomial distribution and the Poisson distribution. All right, so what do we mean by the binomial and the Poisson distribution? Okay, so distributions are there are special functions that we can use to work out probabilities, but we can only use them when certain conditions are met. For the binomial distribution, it has its own conditions, and the Poisson distribution also has separate or different conditions to what the binomial uses. Okay, so how do we know which is which? And that's what I'm going to go over now. Okay, so in this whiteboard, I have binomial distribution there, so we're going to be talking about that. But in the exam or the assignment, you won't know whether it's a binomial distribution. You have to be able to identify that you can use a binomial distribution to work out these probabilities. Okay, so let's just read this problem first, and then I'll explain how to identify that you can use the binomial distribution. So the problem says, once a week, a merchandiser replenishes the stocks of a particular product brand in 6 stores, right, for which she is responsible. Experience has shown that there is a 1 in 5 chance that a given store will run out of stock before the merchandiser's weekly visit. Right, so I'm going to underline some stuff here, right? So because we're going to use it uh, in a bit. So we're saying there are 6 stores. All right, so I'm going to underline that. Okay. Experience has shown that there is a 1 in 5, so that's a probability given there. 1 in 5 is 1 divided by 5, or in other words 20%. There's a 1 in 5 chance, and it even says chance, so that's synonymous with probability, that a given store will run out of stock. Run out of stock. Okay, so basically there are 6 stores, and I'm just gonna put like spaces or place marks for them. 1, 2, 3, 4, 5, 6. Right, there's 6 stores. Now there's only 2 outcomes that we're interested in. They either run out of stock, so I'll put an I'm thinking of a better symbol than X. Let me just put a symbol that they're out of stock as an open 0 O, and or if they have stock as a tick. So they can either be out of stock or they can have stock, each of these stores. So there's only 2 possible outcomes. Okay, and there are 6 stores. So in other words, there are 6 trials or experiments. There's a fixed number of trials. So what we know is there's only 2 possible outcomes. Only 2 possible outcomes. Okay. All right. There are a fixed number of experiments. That is, there are 6 experiments or 6 trials. trials. All right, and these outcomes, okay, they are complementary. Now, I spoke about complementary last time on the last session. They're basically the opposite events. Okay, so let's say it either rains or it doesn't rain. Okay, or you can either have a head or a tails on the flip of a coin. There's only two possible outcomes. It's uh, one or the other. So they you can think of them as the opposite. And because they're complementary, there's this property for probabilities that you have probability of A is equal to probability of, sorry, let me take this out. It's 1 minus probability of A is 1 minus the probability of not A. Now this is just some fancy way of saying if you know the probability that the sun is going to shine, then you can work out the probability that it's not going to shine simply by, let's just say we have a 80% chance that the sun is going to shine tomorrow. 80% chance that the sun will shine. I'm just going to put, so the probability that the sun doesn't shine is 20%. It's just 1 minus that. That's pretty much what I'm saying. So we use the symbol of a dash above it to say not shining. So the sun not shining. Okay, so it's that event. This is your not A. This is your not A would have circled there, and then here this is your A. All right. So that's what this is saying. These are complementary events, and that's what these events are. If you know the chance that you're going to have stock, and they're telling you that it's 1 in 5. So if it's a 1 in 5 chance that you'll run out of stock, then it's a 4 out of 5 chance that you will have stock. All right. They're complementary events. And the last point here I'm going to mention is that these events are independent uh, experiments. So basically what I'm saying is this store 1, okay, store 1 is not affected by store 2, and store 2 does not affect store 3. So if store 3 is out of stock, it's not going to have any effect on the other stores. All right, so these stores are independent from each other. So that's what I mean by independent experiments. Now if these three conditions are met, then you use a binomial distribution. Okay, that's the conditions. These three conditions must be met, and then you know you can use a binomial distribution. Okay, so remember that. Okay, so you won't be told whether it's a binomial distribution. You have to be able to identify based on that information. Now, once you know it's a binomial distribution, then it makes a lot of things easier to answer these questions, right? Because if you get this part wrong, okay, you're going to use the wrong equation for the rest of the questions, and you will get it wrong. So it's vitally important that you identify when it's a binomial distribution or when it's a Poisson distribution. All right, we'll get to the Poisson distribution in a bit. All right, so let's start answering the questions about the text. So the first question is, which probability distribution is appropriate and why? And we've answered that. It's the binomial distribution based on these three conditions that I've just mentioned. So we've answered question A. Now question B is where the calculation comes in. All right. Now it's saying, what is the probability that on a given weekly round, the merchandiser will find exactly one store out of stock? So we have 6 stores, okay? And what they're asking us, what is the chance that any of these stores, it could be this one, it could be this one, we don't care. We just care that one of them will be uh, out of stock. All right. Now for the binomial distribution, what you do is you need to let a random variable, and generally we use the symbol x. We need it to represent what we're interested in. So if you look at the question, it says, what is the probability that the merchandise will find exactly one store out of stock? So in general, let x be the number. I'm just going to use the symbol here for number. The number of stores out of stock. And once we do that, then we can start expressing uh, the question in terms of this random variable. So what they're asking us is find the probability. For question B, they're asking us find the probability that x is equal to 1. If you look at what I've underlined there, it's saying exactly 1 store out of stock. So they want us to find that probability. Now, the reason why I said it's important to identify that this is the binomial distribution is because that'll tell you that you can use this equation here to work out the probabilities. You don't need to remember this equation. You just need to know how to use it. It'll be given to you in your formula sheet, right? Now, if you look at all the symbols in this equation, there's the n, there's c, there's x, there's p. I'll explain all of that to you now, all right? So let me just clear some of this on the right, so I can clarify what those symbols are. Okay, once I explain what the symbols are, it's really simple. You get those values for the symbols from what is in the question. Okay, so if we read the text, and this is why I underlined certain parts in that text, because that will tell us what the symbols are. So, like I said, there are 6 stores, okay? There are 6 stores, and that's your n. Your n is the number of experiments or trials. So your n is 6. All right. Now, remember what I said, a store can either be out of stock or not. Now, we're interested in the chance of a store being out of stock. So did they give us the probability that a store will be out of stock? Yes, they did. It's 1 in 5. So we will denote that as P as in our equation. So P is 1 over 5. I'm just going to write it as a decimal, but you can write it as a fraction if you want. Okay, so 0.2. All right. And I think that's pretty much all we need. We have our n. The c that you see there is what we did last week. It's your counting techniques. So it's, in other words, it's combinations. You'll find that in your calculator above the above the division button. You will see something to the effect of NCR. Now instead of R, they're using X in the equation. So, but it's the same thing. All right. So you don't need to know exactly what C is. C is actually combination. All right. So to work out probability of x equals to 1, we use this equation. All you need to do is replace your x with 1 because that's what we're saying here. We're saying x is equal to 1. So you replace it with the 1 here. So everything in this equation, it's going to be n, which is 6, c combination, and then x is 1, okay, times p, which is 0.2. I'm just going to use brackets to keep my p separated. All right, to the power of x, and your x is 1, times 1 minus p, which is 1 minus 0.2, to the n minus x, and your n is, as I said, it's 6, and your x is 1, so 6 minus 1. Now, if you plug that into your calculator, and I encourage you to start practicing with this, so you'd have to be out of stat mode to work this. It'll make your life a lot easier. To get out of stat mode, okay, remember to press mode in your calculator and choose comp. Okay, number 1 in my calculator, you'll see C or MP. Choose that when you have to work this out. Now, if you enter those values in your calculator, okay, you should get a value of 39.32%. Express your answers as a percent and try to go to 2 decimals at least, or more. More is better, but don't write it as 1 decimal. So 39.32%. Okay. So check anything in the chat. Okay, we're all good. Stefan, feel free to ask any questions if you need to. Yeah, this is what this collab is about. All right. Next, let's do question C. Now, C, the question is asking us, what is the probability that at most, and this is very important, at most, what is the probability that at most 2 stores will be out of stock? Now, when we say at most, and if I say I can take on at most 3 clients, that means I can take on I can take on no clients, obviously. That can be a case where I get 0 clients. I can take on 1 client, I can take on 2 clients, and I can take on 3 clients, but I cannot take on more, right? When we say at most, that means including. So what we're saying is we're saying x less than equals to 2. And this is very important that you have x less than equal to 2. You need to be able to identify when we're including 2 and when we're not. And when we say at most, that means we are including 2. Now x less than equal to 2. So if I'm just going to write this here. If I say x is less than equal to 2, what I'm saying is x can take on the value 0, okay? It can take on the value 1, and it can take on the value 2, but it cannot take on the value 3. So we stop there, right? That's what x less than equal to 2, all right? So when I say x less than equal to 2, now when you're asked to work out the probability of this, you have to work out the probabilities of each of them and add them up. Okay, this is a cumulative probability because when we say x less than equal to 2, we have to take into account all the values below 2 as well as 2. Okay, so we have to work out 3 probabilities and add them up. So now we got to work out probability of x equals to 0 plus probability of x equals to 1. Lastly, plus probability of x equals to 2. And you do this in your calculator like I've done here for you. This is exactly what I've shown you here. This is when x is equal to 1. You're going to do the same thing, but now instead of 1, you're going to replace this with a 0. Here you're going to replace that x there with a 0, okay? And then you'll get another value for uh, this probability, which you will write here. Okay, so we've already done x equals to 1. This value was 39.32%. I'm just going to write it as a decimal. So here it's 0.39 0.3921 sorry 332. This probability here, x equals to 2, it is 0.2458, and I encourage you to work this out in your calculator. I'm just going to add that in space here. 0.2458, and then this probability of x equals to 0 is 0.2621. Okay, when we add them up. And if you add them up, your final answer would be 90.11%. Okay, that's how you work out cumulative probabilities. You have to take into account multiple x values, work out the probability of each of them, and then add them up. All right, so that's question C. Question D is, let's read it, right? What is the probability that no stores will be out of stock? Now remember, X is the event, or it counts the number of stores out of stock. So what they're asking is, what is the probability that X is equal to 0? That's all they're asking, okay? So we've already worked that out in the previous question. As you can see, we've worked it out here. That's the answer. Okay, you want to know what the probability of x equals to 0? It's 0.2621, and that's your answer. So we'll write it as a percentage, 26.21%. All right. And lastly, for the last question, we're being asked, what is the mean number of stores out of stock each week? You don't need to memorize the formula. It's in your formula sheet. Okay, it's in your formula sheet. Remember, this is question D now when you work at probability x equals to 0. For question E, the mean. Let me ask you this question, okay? If and this boils into the what I covered last week. Okay, so let's say you know the probability of obtaining a heads is 50%. Okay, if you flip a coin. So if I flip the coin 10,000 times, we expect half of that. So half of 10,000, which is 5,000, we expect about 5,000 of those outcomes to be heads. Okay, and how we got that is because we took 50%, which is the chance of getting a heads, times the number of trials, which was 10,000 trials. And that's how we got the 5,000. So in the same way for binomial distribution, you only have two outcomes. Just like how you have heads or tails, here you got a store being out of stock or a store having stock. But we're only interested in a store being out of stock. And that probability, unfortunately, is not 50%, it's less. Okay, it's 1 in 5, or in other words, 0.2. So our probability is 0.2 instead of that 50%. So now your average is going to be, and then instead of 10,000 now, how many trials do we have? We only have 6 stores. We're not flipping a coin here. We only have 6 stores in total. So it's your n times your p, and that's how you get your average. But this formula is given to you to get the average. You don't need to memorize it. This is your mu, your mean. This is the symbol for mean. So 0.2 times 6, which will give you 1.2, and that's your average. So on average, you have 1.2 stores out of stock. Okay, even though there's a decimal and you can't really have 1.2 stores, the average does mean it's just over 1. Okay, so it doesn't mean you have to actually use that 0.2 physically, but it means that's your average amount, okay, out of 6 stores. Okay, are there any questions on this? This is basically the binomial distribution. Very important to take away from this is identify that there's a fixed number of trials. In this example, there's 6 stores, so yes, there are fixed number of trials. Also identify, are there only 2 possible outcomes? Yes, they are. You can either be out of stock or have stock, right? And those events are complementary. They're the opposite, in other words. And fantastic. Thanks for the feedback, Caroline. All right. And then lastly, the events are independent. That means each store does not have an effect on the other store. All right. So it's independent. If those 3 conditions are met, that's how you know you're using a binomial distribution. But generally, if you just identify those first 2, fixed number of trials and only 2 possible outcomes, immediately you know you need to use this equation. If you can just get those 2 points down, that'll help you identify that you need to use this equation. Because what I've noticed is what students struggle with is they use the wrong equation, okay? And once you use the wrong equation, then everything goes wrong. So the way to identify when to use a binomial is just check, are there a fixed number of trials, and 2, are there only 2 possible outcomes that are opposite to each other. The moment you identify that, immediately you know you need to use this equation. All right, that's my recommendation and my advice to you. Okay, so yeah, please take that into.
Sorry, sir.
Yes, go for it.
What equation was that you just rubbed out now? You just erased?
Oh, that was, I'm trying to think what I wrote here. That was question number question number C. I was answering question C. So what is the probability that at most 2 stores? So I was trying to work out what is the probability that X is less than equal to 2 at most
No,
2.
sir, not that one. The one that I believe you were explaining it like before you started this question. The one that had probability of A.
Complementary events. So that's basically this. I have probability of A equals to 1 minus the probability of not A. So what that means is, so like the example of the heads and tails of a coin, right? If you know the probability of a heads, you can work out the probability of it being a tails because they're the opposite. That means If you flip a coin can either have this or this. There is no third alternative. They're complementary events. They're one or the other. Another example is, does it rain or does it not rain? If you know the probability of one, then you can work out the other by taking one minus that. Does that make sense?
Yes, it does.
Okay, fantastic. So that's basically the equations I had. And so for binomial distribution, your events will be opposites. So just like how we have here, you can either have stock, so think of A being having stock, and not A being you're out of stock. So they're opposite events and they're complementary. There is no third option. Okay. Um, so that's the binomial distribution. Um, yeah, I hope that makes sense to you. I'm going to close this and now I'm going to move on to the Poisson distribution. Okay, just give me a second. All right, so here, let's read this text, right, before I explain why this would be the Poisson distribution. Okay, so a web-based travel agency uses its website to market its travel products, holiday packages. The agency receives an average of 5 web-based inquiries per day for its different travel products. So just like before, I'm going to underline um, key parts that I'll need later on. So it says on average, okay, an average of 5 web-based inquiries per day. All right. Now, when you're asked to work at the probabilities of a number of events occurring within a time interval, all right, and you're given the average, then it's a Poisson distribution. All right. So the first thing you need to check is an average given? So you basically given an average. Uh, let me just try and write this better. So you're given an average uh, in a time interval, right? And that, if you look at the text, you're given an average of 5 inquiries per day. So that's our time interval. Our time interval is per day, per day, right? And then 2, all right? These inquiries are independent. Okay, so think about it, right? I could make an inquiry, and then one of you can make an inquiry as well with this company. We don't affect each other. We don't know that one of us is doing it, and it doesn't influence the other person. All right. So they're not telling us that there is any sort of correlation or relationship. So it's safe to assume that each uh, experiment is independent. So I'm going to write there independent trials or experiments. And if these two conditions are met, immediately you know that you're using a Poisson distribution. So you would be using this equation now. Okay, so whenever you see time interval, and if there's an average of something occurring within that time interval, immediately you know use a Poisson distribution. And then you're going to be using this equation now to work out probabilities. The A that you see in that equation, that's the average that's given in the text. And that's 5 in this case. So we immediately will write down A equals 5. All right? Don't worry, you're not expected to memorize this equation. It's given in your formula sheet. You just need to know how to use it. All right, so let's look at some of the questions and we can kind of get an idea of how to use that equation. So let's look at question A. What is the probability that on a given day, the agency will receive only 3 web-based inquiries for its travel products? Now remember, this whole thing is about counting the number of inquiries within an interval. for a Poisson distribution, you're always counting the number of events within the time interval. And the events in this case is the inquiries. So you'd always be looking at counting the number of times that event occurs. So we are interested in the number of inquiries per day. So that's what you let x equals to. X is the number of inquiries per day. All right, so question A is asking us, what is the probability that x is 3? Only 3 web-based inquiries for its product. So they're asking us to work out probability of x equals 3. And that's where we're going to use this equation. Okay. For this equation, you actually only need 2 values. You need your a and your x. Your e is actually in your calculator. It's actually a value. It's a mathematical constant. So if you want to work this out, you just plug the values into your calculator using that equation. So it's e to the minus 5, because that's what your a is, as I wrote here, e to the minus 5 times a, which is 5, and now x is 3. Okay, your x is 3, so it's 5 to the power 3, all divided by x factorial, which is 3, your x, which is 3 factorial. I'll explain what factorial means in a second. All right, a factorial just means this. If I say 3 factorial, that means 3 times 2 times 1. If I say 2 factorial, I'm saying 2 times 1. But you don't need to actually write this whole thing out. Your calculator does it for you. For instance, you'll see on your calculator, there's the factorial button is, if you have the Casio calculator, if you look towards the top, you'll see a button that's x to the minus 1. Right? If you look at that button there, above that button, there's this here, x factorial. So for instance, if you want to use the factorial, you need to use shift. So say I want to work out 3 factorial. We know it's going to be 3 times 2 times 1, which is 6. But to do it as a shortcut in your calculator, you will just press 3 shift x to the minus 1, and you should see in your calculator that on your display you have 3 exclamation. Hit equals to, and you'll get 6. So instead of doing it the long way like what I'm showing you here, your calculator can do it for you. Okay, you just look for this button here, and you're going to have to use the shift because you want the secondary function on top. All right, so if you punch it into your calculator, you should get a value of 14.04%. 14.04%. Okay, please, just as a guideline, try to put a statement at the end. Okay, so just say the probability of having 3 inquiries per day is 14.04%, right, for all your questions. The question. Hello? I think someone's mic is unmuted.
Oh, sorry, it's mine, sir. Excuse me.
No worries. Are there any questions or you good?
Sorry, I didn't hear you nicely. Did you say you must write your answers in factorial always?
No, no, no. Write your answer as a percent. Oh, sorry, my bad. I actually put factorial. Thank you. That's actually percent.
Oh,
I meant write your answer as a
okay.
percent, yeah. And then provide just like a statement to interpret it. To say, so what we were being asked in question 1 is, what is the probability that we will have 3 web-based inquiries? So you just say there is a 14.04% chance of having 3 web-based inquiries. Thanks for spotting that for me, Victor. Yeah, I didn't mean factorial, I meant percent. Thank you for that. All right. So okay, so that's question A. Please feel free to ask me any questions before I move on. Even if I have to go back, I'm happy to do that, so let me know. All right, so that's question A, right? Let's get on to question B. Okay, Make some space here. All right, let's go on to question B. All right, B says, what is the probability that on a given day, so we're still referring to the same time interval or per day, that the travel agency will receive, oh dear, I took this out. Sorry, I erased that. I don't even know what the question was. I think it was at most. Okay, it was at most. So just take my word for it. That it was at most 2 web-based inquiries for travel packages. Okay, so they're asking us will receive at most 2 web-based inquiries. All right, so when we say at most, remember what I said earlier, if I say I can have at most 4 clients, that means I can have, there can be a case where I have 0 clients, I can have 1, I can have 2, I can have 3, I can have 4, but I can't have 5. So when you say at most, it's capped at what that value is. So that means we're saying probability that the number of inquiries, which is x, is capped at 2, less than equal to 2. So that means I can have the case where it's 0, I can have 1, and I can have 2, but I can't have anything more than that. So this is a cumulative probability, just like the binomial distribution example earlier. So that means to work this out, I have to work out all of these probabilities. Probability that x equal to 1, sorry, x equal to 0, plus probability of x equals to 1, plus probability of x equals to 2. And you have to work each one of them out in your calculator, just like I did for this example, right? But now your x value changes. So you're going to plug x equals to 0 into this equation, and your a never changes. It's going to be fixed, and you get a value. If you do that, all right, I'm going to work out these two for you. I'll put these two down, all right? I want you to give this one a go on your calculator now, all right? I want you to work out the probability of x equals to 2 for the Poisson distribution. You have your a, here's the average, okay? All you need to do is put 2 where you see x in this formula, put 5 where you see a, and give me the value in the chat. Okay, so do that now for me, please. It's good practice. The first one. Anyone get it? Come on, peeps, at least someone get a value in it. Okay, I heard a noise. I think it's one person so far. Remember, I only want you to work the last one for me, when x is 2. Please give that a shot. Eight four two, Karen, 0.0842. I think that actually is right. Well done. Yes, that is right. 0.0842. Well done. I'm just going to write the second one. So it's 0.336, I think. And then as you got Caroline, 0.0842. Yes, that's right, Victor. You expressed it as a percent. Good. Let's Just going to double check my one here. 0.033. Yes, well done everyone. Very good. Okay, so that's each of them, and then remember we add them up. Okay, we add them up, and that's our final answer. If you do that, you should get the final answer of about tell you now, 12.47%. 12.47%. And then just finish with the sentence. The probability that of having at most 2 inquiries per day is 12.47%. Well done. Good work. All right. Now, what I'm going to finish up with is using the complementary rule. All right. So before I get there, that's pretty much answering the last question. So maybe just give it a read for now, because you're going to have to answer this part here. Give it a read for now. Try and make sense of it. And I will do it now. Okay. So now they're asking us to work out the probability that they'll receive more than 4 web-based inquiries for travel packages. So when we say more than, okay, it's very important that you understand when to use each of these symbols. Greater than equal to, less than, and less than equal to, because they mean very different things, okay? In this question for C, when we say more than, we're referring to this, okay? We're not talking about the other ones, all right? So when we say more than, we use this symbol. So we're saying what is the probability. Now remember, x is the number of inquiries. So we're saying what is the probability that x is greater than 4. Now when I say greater than 4, that means you don't include 4. That means what we're talking about is the events that x, I'm just going to write x here, x can be 5, x can be 6, x can be 7. Now here's the thing about the Poisson distribution. There is no limit to x. For the binomial, we had a fixed number of trials. Like in the example before, there's only 6 stores. You can't go more than 6 stores. But for a Poisson distribution, there is no cap of how many people can inquire in a day. So this can go all the way to infinity, okay? And this is a very important property, okay? Because we are forced to use the complementary rule. And the complementary rule is what I showed you earlier. Victor, this is what you asked me about the equation that I rubbed off. Probability of A is equal to 1 minus probability of not A. Now we have to use this property to solve this problem. Why? Because to work out the probability of x being greater than 4, we have to work out the probability of each of these, 5, 6, 7, all the way to infinity, and then add them up. There is no possible way you can do that in a reasonable amount of time, okay? Especially given you have a 2-hour exam, right? You can't do this, all right? So you have to find a more practical way to do this. And how we do that is we use the complementary rule. Now, what I'm saying is here, when we say probability of A is equal to 1 minus probability of not A, and I really need you to be very focused now and give me all of your attention, okay? This might not be an easy concept to grasp, so just focus. I'm going to use this complementary rule to solve this here, all right? Now, if I'm interested in the probability of x greater than 4, that is the same of taking its opposite and saying 1 minus that opposite. So if I want probability of x greater than 4, what is the opposite of this mathematically? I'm going to give you 3 options here, and you're going to tell me which one it is. There's option 1. I'll write it out now. There's option 2, and there's option 3. All right. Option 1, I'm just going to make some space here. Option 1 is probability, the opposite is probability of x less than equal to 4. Option 2 is probability of x equals to 4. And third option is probability is x less than 4. Which is the opposite of which of these three which of these three options, 1, 2, and 3, is the correct one? Which is the opposite of this? That's what I'm asking you. Is it option 1, 2, or 3? Write that in the chat. Okay, I've got one person so far. Someone else also give it a shot. Doesn't matter if you get it wrong. Good. Let's see. Option 3. It's option 1. Okay, I'm glad I put that out there. It's option 1. Okay, let me explain why. Good, very good for trying. This is the point where you actually try, and even if you get it wrong, perfect. You're saying this, and I understand why you would say this. I completely get why you would say this, because we're saying you're taking the opposite sign. Okay, you're looking at it as if this is greater than, the opposite of that is this. But remember when I told you x greater than 4, right? X greater than 4 means we're taking 5, 6, 7 all the way to infinity. Now if I say x less than 4, if I say x less than 4, then do I include 4? I know I'm going to have 0, I'm going to have 1, I'm going to have 2, I'm going to have 3, but do I take into account 4 if I use this one? And the answer is no. When I say x less than 4, that means I don't include 4. But if I say x less than equal to 4, then I do. And the thing is, I do need to include 4. Because if I didn't, if you look at it, oh, why is this thing going crazy? If you look at what I've got here, 4 is not included. Now I can't have the opposite also not including it, because then 4 has to be accounted somewhere. It can't just vanish. So since 4 is not here, it has to be in the opposite. So that means I have to use this. Do you understand that, people? I'm happy to explain this again if you're not getting it, because it's very, very important that you understand this. If the one event you don't have the number, then the opposite must have it. And it must have all the values below it as well, just because they're not included here. The opposite must have all the values that are not in this set. And the only one that has that is this here, the first option, x less than or equal to 4. So if you went to the third one, you would actually exclude this. And the thing is, 4 wouldn't be accounted in either case. Everyone? Make sense? Thanks, Victor. I think I lost Caroline. Everyone with Stefan? You good? Great, thank you. Awesome. All right. So that's why the first option is the opposite, because if you look at x greater than 4, we didn't have 4 included there. So in the opposite, we have to have 4 included. And the only one of those options between the first and the third one, it'll be this one, because here you have it has to be included here if it's not included here. So the opposite of that is this. So that means using the same complementary rule here that I've boxed, that's going to be equals to, so this is of the left side of the equation here. This is the left side of the equation. It's 1 minus its opposite, which is probability of x less than equals to 4. Oh, sometimes I wish I had an iPad. Okay. All right. So we will solve this because this is doable and we can do this in a reasonable amount of time. So in order to work out this, which is what we're interested in, I'm going to just put a different color here. this is what we want to solve. In order to solve that, we have to use the complementary rule and solve the right-hand side in order to get that value. So all we need to do is we need to work out probability of x less than or equal to 4 and say 1 minus that. So the right-hand side is going to be 1 minus, and I'm going to put everything here in a big square bracket. We're going to have probability of x equals to 0 because we're taking into account all events less than or equal to 4, which is all of these 4, 3, 2, 1, and 0. So you need to find probability of x equals to 0 plus probability of x equals to 1 plus probability of x equals to 2, probability of x equals to 3, all the way to probability of x equals to 4. Okay, so there's 1, 2, 3, 4, 5 probabilities you got to work out and then add them up. And then finally, it's 1 minus that sum. And that's your final answer. So it's a lot of work for this question, but it's very important that you understand how to solve it. Okay, so you use the complementary rule, all right, and that's how you solve it. So you say 1 minus this entire sum here, and you would work out each of these probabilities using this equation, all right? Your x just keeps changing, but your a is fixed. I'll give you the final answer, and you can probably do it as an exercise, which I highly encourage you to do it, okay? The final answer is, so you would have this. Okay, the final answer you would have 1 minus 0.4405, which is equal to, and this is your final answer, 55.95%. All right, so this entire sum part is this here. You will get 44.05% when you work it out. And then your final answer is, don't forget to say 1 minus that too. So you got to subtract that amount from 1, and that is your final answer. Okay, so that's how you use the complementary rule to solve these problems. It's very important for the Poisson distribution because your x is uncapped. Okay, it can go all the way to infinity, so you have to use the complementary rule. Okay, so does that make sense, everyone? That's pretty much all the questions I had on the Poisson distribution and all I wanted to cover this evening. Are you good with this? Any questions? Anything you'd want me to go over?
Yeah, so just something, just so I want to make sure when it
Yeah,
comes to the complementary rule. So if it was the other way around, where x would be greater and equals to 4, right, on the left-hand side, then let's say that's a
yeah,
probability. Then on the right-hand side, would you have the probability of x being less than 4, but without being equal, if you understand what I'm
yes,
saying.
yes.
Yeah.
So it would be, yes, very good. So it would be this, exactly what you said. The probability of x greater than or equal to 4 is 1 minus probability of x less than 4. Very good. That's what you're saying, right?
Yes,
Yeah.
that's what I'm saying.
Yeah, yes. So in this case, the events that you'd only take into account is x being 0, x being 1, x being 2, and x being 3. That's it. You wouldn't take 4. Fantastic.
Okay, thanks.
Yeah, so that's why I didn't want to cover the normal distribution this evening. I think that would have been a bit too much. So I covered what we call the discrete distributions. What I mean by discrete is your x values, so far they're just counting. So they can only take on whole numbers or discrete numbers. That means they can take on values of 0, 1, 2, 3, etc. They're counting numbers. That's what we mean by discrete distributions. We're generally using a random variable that counts events. But in the next lesson, your x will take on decimal values, and that's when we talk about the normal distribution, but that's the next session. So today, the takeaways were the binomial distribution, the Poisson distribution. Identify when to use which, and once you establish that, you need to know how to use the equations for both of those distributions to get the probabilities. All right. So yeah, I hope this session helped. Um, and that's all I wanted to cover for this evening. Next week will be the normal distribution. You're welcome. I'm very glad to hear that. Have a good evening, everyone.